Okay, this evening I want to talk about significant digits. It's a concept we will need in doing our PBL erosion project and in taking other measurements. And because of time, I'm doing it on here and putting it on YouTube rather than we may be limited in our time in class. So the first thing to remember about significant digits is just the definition. It is defined as a measurement that consists of one, of all digits that you are certain of, and one digit that you are not sure of, that you had to estimate. For example, if I measured a distance of 4.51 centimeters, that would let me know that, or I'm sorry, wrong number, 4.6 centimeters. That would let me know that on the ruler, I'm sure of the 4, but I had to estimate the 6. Maybe it wasn't right on the line for 6. Maybe it was a little bit between, or a little bit one direction or the other. So I estimated the 6. I wasn't sure of it. Now, if I was sure of the 0.6 and my measurement fell right on the line for 0.6, then I would say my measurement was 4.60 centimeters. Okay, so you can see the difference between the two. I was sure of the 4, I'm sure it's on the 6, but I'm not sure about that last digit. I had to estimate or think it's right. It's not over one way or the other. Okay, let's look at some of the rules for figuring out significant digits and using significant digits. What measurements, how many significant digits are in a particular measurement. The way I'm going to do that is, first off, all non-zero digits are significant. So all you need to do is just count how many non-zero digits there are. So if we go back up to my example, 4.6 centimeters, that would be 1, 2 significant figures, and I just write sig figs. Okay, so that's 2 significant figures in that measurement. That just lets me know that that measuring instrument, whatever it is precise out to 1 decimal place. And I'm sure of my measurement out to 1 decimal place. The problem comes in zeros. Okay, so for zeros, whether or not a 0 is significant depends on the presence of a decimal. Whether or not there is a decimal. Okay, so to help us remember that, I'm going to use a little mnemonic about using the map of the United States. So I'm going to try and draw a map of the United States. Probably not going to look very good. Oh well, something like that. So this is the United States. And in a number, it's going to represent our decimal place. Okay. On the right side of the decimal place, we have the Atlantic Ocean. And on the left side, we have the Pacific Ocean. P in Pacific means that your decimal is present. A in Atlantic means that it is absent. No decimal place. Okay, so what I'm going to do is, if my decimal place is absent, I'm going to start at the end of the number and I'm going to move to the left until I hit a non-zero digit. So everything from the first non-zero and left is significant. So let's look at an example. If I took 15,000, okay, there is no decimal place there, so I'm going to move from the end of my number and I'm going to count everything till I'm going to find my first non-zero digit and I'm going to count everything to the left from my first non-zero digit left. So that would be the 1, the 5, and the 1. There are 2 significant digits in that number. Then I'm going to come over here and we'll work some other examples in just a minute. But if I'm on the Pacific side, I have a decimal present. I'm going to go to my first non-zero digit and move to the right. So everything from my first non-zero and right is significant. Okay, so here's my example. 0.00225. I'm going to move to the right, find my first non-zero digit, and I'm going to move to the right. And everything to the right of that first non-zero digit, the first digit and to the right, will be significant. So this number, the 2 and the 5, are significant. So there's 2 significant figures. Okay? So what we're going to do now is look at a couple more examples. So I'm going to move to a new slide. And let's look at example number 3. 0.030. I have a decimal present, so I'm going to find my first non-zero digit, and I'm going to count from that first non-zero digit to the right. And everything from the first non-zero digit and right will be significant. So here there's 2 significant figures. Let's try another one. 0.00320. So I go to my first non-zero digit and I move to the right till I come to the end of the number. So that it's going to be the 3, the 2, and the end 0 is significant. So there's 3 significant figures. Okay? Both of those examples are important because in math classes you would just have dropped that last 0, or that we call it the trailing 0. You would have dropped it off. But it's important to keep it with significant digits and with science measurements because it tells us that our measuring instrument, whatever it is precise out to that decimal place. So this measuring instrument would be precise out to the 10,000th place. Oh, I'm sorry, the 100,000th place. This measuring instrument, whatever it is precise out to the 1,000th place. So it's very, very important that you don't just drop off a trailing 0 in a measurement. Okay. Let's look at example 5. $252,000. Let's put a unit in there. Say meters on these, because every number has to have a measurement with it in science. So this does not have a decimal place present. So I'm going to move from the first non-zero digit. I'm going to come along from the left, from the first non-zero digit and left, everything is going to be significant from that first non-zero digit moving to the left. So that's the 2, the 5, and the first 2. 2, 5, and 2. 3 significant digits. Alright, let's take a look at a number like this one. 205. Okay, there is a 0 stuck in the middle, and there is no decimal at the end. But because that 0 is in the middle of two non-zero digits, it is always significant. So zeros between two non-zero digits are significant, always. So this has 3 significant digits, significant figures. Okay, let's take a look at this number, 25.023. Okay, I have a decimal present, but this 0 is also in between two non-zero digits, so that automatically makes it significant. So this has 1, 2, 3, 4, 5 significant digits. Okay. All right, let's look at how we do calculation. Okay, so let's look at another example of adding and subtracting. 2.301 plus 5 plus 5. If I add that up, I get 7.301. If I leave my answer like that, what I'm saying is that my calculation is accurate out to the third decimal place, which can't be true if one of my measurements is not accurate out to the third decimal place. So my correct answer, I have to round it so that there is no decimal place present. Okay, so I would round it to that first place right there where there's no decimal place. My answer cannot have a decimal place, so it would just be 7 meters. If I did a subtraction one, let's do 545.30 minus 45.1. 02005. Okay, when I'm looking at this, I'll see that this only has one decimal place, which means my answer should only have one decimal place. So my correct answer is actually 500.2. You would round to that first decimal. Okay, now let's look at rules for multiplying and dividing. When you multiply and divide with measurements, what do you do with the significant figures? Okay, the rule is that your answer can only have as many significant digits as the number with the least significant digits. So if I look at 2.0 times 3, this number here has 2 significant digits. This number here has only 1. So if I multiply that out, your calculator might give you 6.0, but I can only have one significant figure, so that means 6 meters squared. Each of these is meters. Okay? Let's look at another example. Times 3.1. So 2.51 times 3.1. The 2.51 has 3 significant digits. The 3.1 has 2 significant digits. When I multiply that out on my calculator, you are going to get 2.51 times 3.1 is 7.781. Now you cannot leave the answer that way. You can't just take whatever's on your calculator, because when you do that, you are saying that this measurement is accurate out to the third decimal place, the thousandth place. But this measurement only has 2 significant figures, so you can't possibly be that accurate. Your answer has to be rounded so that you only have 2 digits in your answer. You only need 2 digits in your answer. So when I do that, I look at rounding this 7 right here. I look at the number behind it. It's going to round it up. So my answer should be 7.8 centimeters squared, which only has 2 significant figures, like this measurement only has 2 significant figures. Let's look at another. Let's take 2.64 and divide it by 3. Okay, if I do that, this has only 1 significant digit, this has 3, so my answer can only have 1. When I divide that out, 2.64 divided by 3, the calculator answer that's given to me is 0.88. I cannot have 2 significant digits. That's more than my least number of significant digits. So what I have to do is I have to round to this first place, because I only need 1 digit. So because that one is over 5, it's going to round up, giving me my answer of 0.9. Let's say that's grams, whatever the measurement is. Okay. Alright, I hope this helps with significant figures, and as we're doing measurements that you remember to use the proper significant figures. All of my tests are, the numbers used are in correct significant figures, so when you do a calculation you'll need to put it back in significant figures. And you will earn points based on whether something is in the correct number of significant figures. So please make sure that you practice this, and that if you have any questions that you ask me in class. Thank you. Goodbye. There's basically 2 rules. There is a rule for adding and subtracting. And the rule for adding and subtracting says that you must have the same number of decimal places as your answer with the least decimal places. So if I'm adding 2 measurements, like 4.51 meters, and I'm adding to that 4.2 meters, okay, if you add that up, put it on your calculator, whatever the answer you get is 8.71 meters. But because this is only measured out to the tenths place, my answer cannot have more decimal places than that number. So I'm going to have to round it to the first decimal place right here, which would mean that my actual answer is 8.7 meters. That's my correct answer. And you are not supposed to have more decimal places than the least number of decimal places. That's saying your answer is more accurate than any of your measurements, which can't be true. Okay, so that's our rule for adding and subtracting. Let's look at a couple more examples of that.